Hello and welcome back to the Broentech learning video series. Today we will see the gateway software, and in particular the Python version, which we call it PyGateway. You can find this code on GitHub repository on our GitHub repository, github/Broentech. So let's start to see that we should start by saying what this software does. Is basically read the data from serial and store it. There are three threads. Basically, the first one is to read which reads data from serial and store it as a file, as a BRN file. The second thread will read this BRN file every X second and try to send it online. The third one will actually and if the second thread fails to send the data online, it actually gets the data gets stored as a JSON. And then there is a third thread which basically reads this JSON from time to time and try to send it online. So here we can see, let's start to see the code. First thing to notice is that this is released under MIT license, which you can basically means that you can reuse it and do whatever thing you want with it. Here in the main there are some definitions. The first one is data in local folder and JSON in local folder. So this means that the first thread, let's start with this. The first thread is basically read the data from serial and store it in a local raw data.brn file. And if this variable is set to true, it basically means that this file will be in the same location of the main file. And this is always the case if it's a Windows 32 platform, or if this is set as a local folder. Otherwise, if it's not, then will be stored in this location. The same things here apply for the JSON in local folder. If it's set to true, the JSON file will be stored in the same location. Otherwise, will be stored in this location. You can change here the location as you wish. There are another two very important variables here. The first one is sleep time, and the second one is retry time. Sleep time, this is set to 5, and this basically defines how often. This is expressed in second. It will check the presence of the data file, basically this raw data.brn. So, and this one basically in this case every 5 seconds we'll try to see if there is this file. We'll convert it to JSON and we'll send it online. If it fails to do that, it will actually store it in a JSON file. That's it. That's what the first thread does. The second thread will actually will wake up from every 30 seconds. We'll check if there are any unsent data like the JSON file, and if there are, we'll actually try to send it. If it's not, then we'll actually just will not do anything. We'll just skip it and go back in 30 seconds and try it again. So here in the definition of the main, we can see that there is a log handler, which is a library which we create for logging information, and we'll basically print out some information about about the device, and in particular we print out the MAC. So, and this is very important because we will need this information. You will need the MAC address for registering the device on our website. You will see this one in a later video how to handle it. So then yeah, it will also say where the logs are stored and where the other things are stored, for example the file, the raw file, and so on. This one we also initialize the position because in particular is in utility.position. Utility is this library here which basically contains some useful data, and in particular useful functions. In particular the need position, which basically we are only requesting from a website now. Try to get the position from the IP. And yes, and then we extract the value of latitude and longitude. If we fail it, then we just initialize it by NA. So you can even remove this one from. If you're not interested, you can just comment this out or implement these functions as you wish. If you have like a GPS implemented, then you can just read the position from the GPS directly. Then we start to log the token, load the token. Basically, the token is the password used for authentication in our backend. So if and then here we create some path. So, and here we start to get something interesting, is the login handler. These functions, we will see, basically we try to initialize the token, and now we see what the login handler does. This is basically the library. So you can see here again, here we have some definition where basically we define the certificate of the website and so on, and also we have the URL of our backend where it has to fetch the token. So, and basically we were saying that that the main functions as was calling the function called init token handler. Basically this one will get basically initialize the token, and will try to will try to fetch the token from file. This means that every time that the software starts, it basically tries to load a token, and the first thing that it will do, it will check if it's stored online somewhere. If it's stored online here, then it will load it, basically f.read. Otherwise, it will just continue and try to fetch it online. So you see, if this is fail, if the token is -1, this means we were unable to load it. Then we'll try to fetch it online using myMac as a variable, and basically this one will try to, where is the fetch online token? Yes, I will basically start to request token, and if it's 200, then it will extract the token from the JSON which we receive. Otherwise, it will get 204. Then means that the token has already been fetched. And so this means that you cannot fetch it again for security reason, and or if it's 500, that means that there is something wrong. Probably you did not add the device on your portal, because the first thing that you have to do, you have to add the MAC address of this device on the portal, and then the device will be able to fetch a token. So you have basically to authorize the device to generate a token. After this, you see, yes, so basically what it does, and if it's able to fetch the token properly, then it will basically store the token. So next time we will have it stored in local, so we don't need to fetch it again from online, but it will be stored in a file, and the file where it's stored is basically set here. Yeah, it's set in these folders. Let's see where actually we store the token. Store token. Yes. Yes, we write the token in this token file. This is the variable which we should check. Yeah, source here. So it's basically in the same certificate, in the same folder of the certificate, and it's called a token file. So very important for security reason, you should give this token file access only. You have to set the reading and writing permit of this file very strictly, because this is the password which will be used to send the data on our cloud. So if someone gets this token file, he can basically use the same MAC address of this guy and the token file to send the data in behalf of this guy, and this should not happen. So just protect this token very well. If it fails, if you think that this device has been compromised, then you can just regenerate a new token from online. Yeah. So once that we have the token, then we start 3 threads. You can see the first one is the serial handler.read. Basically we pass this is the first thread. Let's start to see what the first thread does. Serial handler, and in particular this one will actually start to see the main things that we call is read. In particular, we get the path from the port, and this one will basically give us a list of the port which contain useful data. If this is the serial port, then if this is correct serial port, then we basically open it, and we align basically the data that we are receiving. We basically align the datagram, and we start to extract. We basically start to give me data, with these functions, which basically start to read data from the serial. And we check the datagram. If it's correct, then we store the data in the Broentech .brn file, in the data.brn file. Otherwise, we have an error, means that the port has been disconnected or something has happened. So we basically disconnect the port, and we basically try to refetch a new port again. We start to check. Basically, what we do, all this stuff here is basically for this function here. We basically looking for datagram. Firstly, we look for a port, and then we try to read data from the port. If there is some data coming out from the port, we are not sure that actually are the datagrams that we are looking for. So what we do is we try to fetch to align it with a $sign. And if we do it properly, then we should be able to fetch the datagram out from it. And if this datagram is correct, then we basically start to store the data and read that from the serial handler. So, and this data will actually be stored in a file which is called the BRN file. These variables here, which we pass it when we launch it here in the main. You see, this argument is raw file path, which basically is this file here. So we can see that the first thread, what it does is read data from the serial, looking for a specific datagram, and store it as a raw data.brn. The second thread here, it's the data handler, and basically will accept the raw data path as arguments, the sleep time, and the file no connections, means that when we fail it. And this datagram is this thread, what it does, data handler, here it is. The data handler, what it does is basically start to look for data handler. What it does is basically start to look for a JSON. You start to look for this data file. If the data file exists, then it will basically convert it to JSON and try to send it. If it's not, if HTTP send fails for some reasons, because we don't have any internet connections, or because the token was wrong, or because whatever reasons you may find, then we log it, and we log the that we are unable to send it, and we basically store the JSON. And we of course remove, since now the data file is stored as a JSON, we also remove the data file and we log it. Yes, otherwise, if there was no data file there, then we also say that we didn't find any data file in this location, and we'll try again in sleep time seconds. So this variable is set on the main, and it was 5 seconds. So basically every 5 seconds, this thread here will try to look for this file, and if we find it, we try to send it. If it failed, it's stored as a JSON, and so on. I will continue doing this forever. So we can see here that there is something even a little bit more complex, because we don't want that this JSON basically grow up forever. If we miss the internet connections and we try to send it and we fail it, and then we store it as a JSON, and we continue doing this one forever, if the internet connection never came back, this JSON will basically grow up, and this JSON file will basically continue growing until it fill up all the memory. And that's why we found something. We found a solution on that by doing basically rollover. Basically, we store only a certain number of only a certain number of JSONs and and only a certain number of it, and up to a certain size. So you can read the code here, and basically here you can find it. For example, the maximum number of JSON files and the maximum size of each JSON file stored. Actually, this should be 200,000 here. Yeah, because we want to basically with this configuration here, we will only get maximum 9 JSON file of 100 kilobit each one. So this means that if we don't have internet connection, we start to save it data as a JSON, and then we start to fill up the first file, and then the first file became the second file, and then the third, fourth, up to 9. If the internet connection did not came back when we fill up the 9, then we basically do a rollout. So the first one became the second one became the third one, and so on, and then the 9th file will become the 10th, but the 10th actually will be removed. So you only keep up to 9, the latest 9 files. So, and each file will be a maximum 100 kilobit, more or less. You can change these parameters if you want. Yeah. So, and when the connection will came back, so this thread will read all these JSON and will be send it in one time. Basically, as soon as the internet connection came back, it will actually push all the 9 and delete it. So you basically refresh the kind of refreshing the buffer. So now you have again another 9 JSON file to fill up. And here there are a lot of functions for converting from and JSON data. You know, you can read it and find something interesting. And here you have also all the possible response from the server. If the JSON is wrongly formatted, or if the JSON was too big, then you should remove it. Or you can even, if you try to post a JSON on the website, you also may get 401, means that you didn't get unauthorized back. You got unauthorized back. This means that you need to fetch a new token because the token was wrong, and the system automatically call init token handler. We basically will these functions which we saw it before. We take care about the fetching and try to fetch a new token. So, and this basically is the second thread. The third thread here is the stored JSON handler. Yeah. So the stored JSON handler, and with this basically what this function does is still easier than that, the one before, which will basically try to read the data from the JSON. Yeah, this actually was the one which is reading from the JSON, and we'll just try to push it on the cloud without doing anything. So we'll read if there are JSON available, we'll just push it online, and this will be called from now and then. If there is internet connections, if there is a stable internet connections, this thread will basically never do anything, because there will be never a JSON stored in your system. Because the data will be read from the Broentech file and will basically just be sent online directly. If the internet connections are unreliable, then will be stored here online, and this basically this thread will actually looking for it and send it. It is important to notice that for avoiding concurrency problems and because for multi-threading, in case that we get 401 back, basically this function will not do anything, because there will be the other function taking care. You see here there is the other thread which will basically respond to the 401 case. So if this function get 401 back, it will basically just ignore it and continue doing. Yeah, we failed to send it the JSON, and we log it, and that's it. So the next time that the serial handler will try to push data online and will get 401 back, then is that one functions which will basically invoke the init handler function, the init token function, and take care about that. So I think this was an overview. Here we can see it. For example, here I have some example of the data which are stored. For example, these are the data read from the serial port. So you can see this is the datagram formatting which we explained in a previous video. and also that you can find it well documented on GitHub repository. So basically here this is a $02802, this is the datagram board name, basically is board name. The $A is for alignment, and then there is basically the dollar is for alignment, and then there is A02, which basically is the board name. Then there is another 4 char here. This means that is a temperature sensor, and this is this means that is a digital floating point. So basically this is for it's a float basically, and came from a digital sensor. And then you have a C, you have this 4 character here. This means that you have only one number encoded here in this number, so we have only basically one float. If you will have like, if this will be an accelerometer, then you will have X, Y, and Z values. So when you basically unpack this structure here, you will get 3 values out from it. So you will need to consider 3 values of this 12 byte. After this, you will get the 4 alignment, the 4-0 alignment here. You see, this is also used for alignment, and this is the datagram that we read it from the serial. Plus, we also added this other strange number here that you will not see. It seems they are unreadable because they are bytes. But if you read all these bytes and you convert it to a int, then you will get the timestamp. So this is the timestamp at the end, and so on. Basically, this is the raw data.brn. You can see how they look like when we are reading from the serial. Of course, if you this is a datagram that we have it used until now. If your datagram is different, you just modify the functions and for reading your own datagram and parse it correctly. So because the backend, what is interesting from the backend is that you will send a JSON to our backend. So in the JSON format, it's you can see it from the data handler, how we basically create a JSON and so on. The other things is the token handler, the token file here. So here you can see this is basically an example of a token. So the token file will basically only contain the token, and with this file will be loaded at the startup time if there is. If the server will answer unauthorized back, then the system, this software, will automatically delete this file and try to fetch a new one. So yeah, very important. And here you can see even the log file. So an example of the log file which is generated. You can see that at startup time you will get let's see where is the startup code. This has been running for, yeah. So for example, yeah, sorry, I was reading from, yeah, here for example we can see that this is a main run. Broentech started on device running on Windows 32 with MAC address, blah blah blah, and so on. Yeah, and yeah, so where it's storing the data, and how it's possible to do all this stuff. Yeah, you see, and when we find something interesting here, we say, hey, useful data found on Broentech battery float AD. So and if you have, we also create something, some sort of error here. Where we fail to parse our row. Basically, we fail to convert our row from the Broentech to the Broentech file to the JSON. So we logged it also, that one. And yeah, so you can see that this you will find a lot of information in case that the token, these functions may say, hey, we are not able to find it to initialize the token properly, so please go and fetch a new one. Or you will find something, hey, this we are looking for datagrams in port COM5, so you can already double check and debug it if there is something wrong, and it will tell you also if it has found some useful data, and it will actually print out the first data that it has found. Yeah. So I hope that this was informative. This is the code. Please go on GitHub and see, download it, test it, modify it as you want, and you can even give us feedback. So this was an initial release, so we've been testing it on Raspberry Pi, and everything worked yeah, everything works as we expected. So yeah, there may be other bugs or there may be some things, but it's, you know, the code is there and you just use it as you best wish. Yeah, so thank you for attending this class. So I hope to see you the next one. Thank you.